Can everyone hear me? Okay, cool. So yeah, today I'm just going to talk about rsparkling. It's a package that was made at H2O AI. It was made in response to the sparklyr package that RStudio came out with shortly before that. So here's the quick agenda for today. I'll go over what is H2O or who we are as a company. I'll briefly touch on the H2O platform. Then I'll jump right into H2O sparkling water, which is running H2O in the Spark ecosystem. I'll briefly touch on sparklyr, then rsparkling, and then I don't have the demo on this laptop, but if anyone's interested in seeing a demo of rsparkling, just come see me after and I can show you on my laptop. So H2O AI is a company, a machine learning company located in Mountain View. We're about 65 people. We've been around since 2012. The company was founded behind a lot of Stanford math and systems engineers. H2O as a software is completely open source. So if you want to see the source code, you can go on GitHub, that link posted there, and see everything we're up to. We also have an ease of use web interface, H2O Flow. This is a way of ingesting data and running machine learning models through a web UI. We also offer R, Python, Scala, Spark, and Hadoop interfaces as well. So here's a list of current algorithms that we have to offer. So when it comes to certain statistical analysis, we offer GLM, naive Bayes. We offer ensemble algorithms, so that's like random forest, gradient boosted machines. We also offer this other ensemble technique called superlearner. This is a technique in which you combine multiple models to gain higher predictive performance. We offer deep learning. In the core H2O package, we offer feed-forward neural networks. So that's the simple MLP type algorithm. We also offer autoencoders, anomaly detection, and another thing called deep features, which is a way of getting features from a deep learning model and to use in another model. When it comes to unsupervised learning, we have k-means, dimensionality reduction, and the certain type of data munging you would expect, so group bys, sorts, statistical functions like mean, standard deviation, et cetera. Those are all offered in the H2O package. So H2O itself can run in a multi-node cluster setting. All the computations are in memory, and each node only sees some rows of the data. So it's basically our own flavor of MapReduce. There is no limit on the cluster size as well. H2O runs on a distributed key value store. So every object in H2O, whether it be a frame or an algorithm, it has a key, and that key can be referenced by any node in the cluster. The H2O frame itself is a distributed data frame. So it's a distributed data frame of vecs, where a vec is a column, and each partition of a vec is you can think of it as a chunk. So it's a chunk of data that's sent over to multiple nodes in which we can run computation in a MapReduce manner. So H2O itself prides itself on running extremely efficient machine learning algorithms on huge amounts of data across many nodes in a big cluster. That's where we sort of prize ourselves in. So now I'll jump into sparkling water, which is a way of running H2O in a Spark cluster. So sparkling water is sort of a transparent integration of H2O into the Spark ecosystem. So H2O will actually run inside of the Spark executor JVM. So it's pretty transparent in that sense. It's pretty much like starting a normal Spark cluster. So the main benefits of this is Spark itself has its own machine learning library called MLlib. The benefit of using sparkling water is you can take advantage of the efficient machine learning algorithms that we offer. So for example, H2O's GBM, H2O's random forest, H2O's feed-forward neural networks, k-means, et cetera. So all of these can be run inside of your Spark framework. And you can also utilize Spark's data munging capability. So you can imagine a workflow in which you're doing data munging using Spark SQL, and you're taking that frame over to H2O to finish off with your machine learning model. And also down here is just showing how to start a simple Spark shell. It's really no different than how you normally start a Spark shell, so that's where the whole transparency comes back in again. So these two are tightly coupled, and there's really, I mean, in my opinion, there's really no complication to it. There's really no two separate processes that have to be done. You just need the jar, and you're ready to go. So here's the sparkling water ecosystem. So sparkling water can, of course, be run in Scala, and this is how you would normally start a Spark. This is how you would normally start a Spark context in Scala. We also have a Python interface, which is called PySparkling, and this, of course, is how you just start a Spark context as well. It's just a call to Spark context, and then you're in there. You're running PySparkling on your Spark cluster. And the last thing we have is, that was recently added, is rsparkling. This is a way of running your R interface on top of your Spark cluster. So I'll briefly touch on sparklyr. There was a talk earlier today from Javier from our studio. He mentioned a lot of the ins and outs of sparklyr, so I won't repeat those. I'll just kind of go over the high-level structure. So sparklyr allows you to connect to Spark from R. It uses a dplyr backend. So dplyr is basically like, it's a SQL-like language in R. So it uses things like pipes and all these type of things to do group bys, to do mutating type functions, anything like that. But it's pretty sequential in that sense, and for someone who doesn't really know much about SQL, they can probably pick up dplyr pretty quickly. And down here, we have a common way to start sparklyr in R. So those of you who are familiar with R, you would basically just do a library called sparklyr. You can install a version of Spark. So in this case, I'm going to install Spark 2.1.1. I can do a connection to a local instance. So basically, this is if I was running Spark on my laptop, for example. And then down here, it's just doing this copy to command. So what that's saying is, take my Spark connection that I just made called SC, take the iris dataset, and put it on my Spark cluster. So this ties closely to what I was showing with sparkling water. So sparkling water runs H2O in your Spark cluster. So then what sparklyr does is sparklyr allows Spark to run in your R environment, and then this will lead into rsparkling. So what rsparkling does is going to tie together with sparklyr and allow H2O to run in your Spark cluster that is utilizing, or that is running behind R. So rsparkling itself is basically just an extension package of sparklyr. We utilize a lot of the functions that sparklyr has to offer. We're just offering all the algorithms we have as a software. So once again, if you want to start up rsparkling, you could do a library called sparklyr. You can get your version of Spark that you're interested in using. And then you have to install a specific version of sparkling water using this command. So we're utilizing R's global options command, and we're setting the version of sparkling water we want to use. And what this would do is, if let's say you're connected to the internet, this will just fetch it from Maven, bring it down, and then you would have that version of sparkling water. The main thing you have to keep in mind is the major version of your sparkling water has to match the major version of Spark. So if it's Spark 2.0, you should have 2.0 dot something of sparkling water, and it'll work just fine. Once you have the proper settings enabled, mind you, these are the bare minimum settings. So this is if I was running like on my laptop. I'm not on a Yarn cluster or anything like that, so there's minimal configuration. For extra configuration, I would just advise you to look at the documentation. It's pretty straightforward in that sense. Once that's done, you could do a call to rsparkling, and then you can connect. And then once you connect, you're running rsparkling and sparklyr in tandem. So you're basically running the sparkling water instance inside of your R environment. So here's sort of like a typical example of how someone would use rsparkling. So you could have RStudio running on one of your edge nodes, and then through your edge node, you can have, let's say, like some Yarn client where you've established sparkling water plus Spark. through that, you can utilize your R interface to do either data munging, pipelines, predictions, anything like that on a Yarn cluster running Spark. But all the nitty-gritty of utilizing Spark is kind of abstracted away. You're kind of using what you're used to if you're an R user. You're using dplyr, using ggplot to visualize data, all these nice things that aren't too complicated and are pretty straightforward, and you can kind of iterate very quickly in this manner. So here's like a typical use case of using sparklyr with rsparkling. So you can imagine you have some data source. You ingest this data source in whatever manner you so choose that Spark can support. You utilize sparklyr to do a lot of your data munging. So it'll be using dplyr, but all of that will be translated to Spark SQL commands. So imagine doing like a group by, or you're doing group this by this, give me the mean or standard deviation, doing some targeting coding for your machine learning algorithms, anything like that. You could do all that in sparklyr using dplyr. Once that's done, you can take that frame you just made, that Spark frame, data frame you just made in R, convert that to an H2O frame. And then once it's converted to an H2O frame, you can utilize H2O to run your final step, which is usually a prediction problem, or maybe even some unsupervised learning problem. And this is sort of the second use case, which is kind of flipped. So you import the data in H2O. You do some maybe munging or a minimal munging, or maybe even do some predictions already to make new features or something like that. And then you take that to an ad hoc analysis in which you use sparklyr and H2O in tandem. So these two use cases are what I would say are the typical ones I've seen from customers or people in the community. They utilize sparklyr to do a lot of the data munging, and then they utilize H2O to do a lot of the predictions. And this is the same concept that gave rise to sparkling water. There was this need for more sophisticated machine learning algorithms in the Spark community, but Spark itself was very good with Spark SQL, in my honest opinion. I think Spark SQL is great. So sparkling water came about by putting the two together, putting high-performance machine learning with high-performance data munging, pipelines, et cetera. And once you put those two together, you're able to come out with a lot of great things, a lot of great results for your data science problem. This is when I was going to show a demo, but of course, the demo's not on this laptop. If anyone wants to see it, I have one on my laptop. And here's some contact information. So rsparkling is on GitHub, so if anyone has any issues or wants to contribute, you're more than welcome to. You can email me here, so navdeep@h2o.ai. And also for anyone from the Bay Area, the Warriors are playing today, so let's make sure we go out there and watch that game. Okay, thank you.
Any questions, or let me give you a mic.
Is H2O going to be expanding the deep learning algorithms into other types that aren't currently available? Is that on the plan?
Sorry, what was the question?
Is H2O planning to expand the deep learning algorithms beyond what you currently have?
Is it planning to expand the
types of deep learning?
Oh, types. So,
yeah.
So right now H2O3 has a it runs all on Java, and then the first or the only deep learning offering we have in H2O3 is a feed-forward neural network. That is what is offered. But H2O3 also has another product called Deepwater, which is in which we combined, the backends of like TensorFlow, MXNet, Caffe. Well, right now it's Caffe 2. We're working on Caffe 2. And those are GPU enabled. So those are really more of the deep learning use case you would want. If you're doing something like images or speech recognition, anything like that, anything that's compute intensive, you could use Deepwater for that, as long as you have, a GPU. So if you have if you're lucky enough to have like a DGX one or something like that, you could probably.
What is the timeline for that?
It's already out. So the first version of Deepwater is out. So if you go to the H2AI/downloads, it should be there. And we have a README with instructions on how to set up your environment and what hardware is needed, of course, and you can follow along with that. We also have a Docker image for it as well that we use. Yep.
Now, you mentioned that H2O can be integrated with Spark. So my question is, when we start the Spark work thread on one node, how many work threads should we create? Because I assume H2O spawns its own thread or not?
So H2O will actually, so the question was how many, I guess, workers,
thread, yeah.
Yeah, threads you should spawn for H203 when you're running in Spark.
Right.
So H203 will run in the Spark executor. So whatever Spark has to offer, H2O will be using that same thing. That's how sparkling water works.
For example, if the CPU has 20 cores and I initiate a 20 work thread, like it's a typical configuration, and then I'm wondering how you because each H2O algorithm just working on each core, or it will need to be parallelized running on other cores as well.
So in the sense of sparkling water, H203 will work on whatever amount of threads or anything that you're offering to your Spark cluster. Whatever you're offering, that would be available to H203. We're not even H203, we're talking about sparkling water. So H203 is a separate thing. Okay. H203 is if you're not using Spark, that's H203. Sparkling water is if you're using Spark plus H203. So if you're using that, they're all under the same umbrella. They're all under Spark, that Spark cluster you have running.
Okay.
Yeah.
Okay, thanks.
Do we have any other questions anywhere? All right, great. Thank you.